Have you ever, taken a pair of pruning shears and chopped the top off a fiddly fig? Because if you do, it's going into immediate shock.
Oh, absolutely. Yeah, it's going to struggle.
Right. And if you take those same shears
Yeah.
and just totally decapitate a tomato plant, I mean, you were probably just going to kill it outright.
Yeah, that's pretty much game over for the tomato.
Exactly. But if you take a pair of regular kitchen scissors and completely level a pot of chives, like shaving it right down to the soil, it doesn't die. It actually comes back 2 weeks later, twice as aggressive.
It's basically a biological cheat code.
It really is. And that's exactly what today's deep dive is about.
Which is great because it completely upends how we normally think about plant care, We are so conditioned to treat plants incredibly delicately.
Yeah, preserving every single leaf.
Right. So the idea of hacking something down just to force it to thrive, it feels completely counterintuitive.
It does. And we've got our hands on some really fascinating notes from a nature and innovation class that cover this. And honestly, they read less like a standard biology textbook and more like a rescue mission.
They really do.
Yeah. So we are going to follow these two students, Kesser and Steen, as they attempt to resurrect what looks like a completely lifeless, tragic pot of dirt. And in the process, we're going to unpack the hidden biological engine that makes chives practically indestructible.
And by the end of this, we're also going to look at the math of how you can turn one really ugly lump of dirt into an endless money-saving supply of fresh herbs for your kitchen.
Right. It's really a masterclass in looking past the superficial appearance of a dormant plant. So to really get why this matters to you listening, we kind of have to set the scene of what Kesser and Steen are actually dealing with.
Yeah, it's a very relatable situation.
Oh, totally. They are currently in that messy, uncertain, early spring phase of germination. They've got this whole setup going with cardboard paper towel tubes that they're using as makeshift seed starters.
Which is, a very resourceful, albeit chaotic, way to start a garden.
Highly chaotic, especially because the notes point out a massive flaw in their plan. They are staring at these tiny, hair-like green shoots poking out of the cardboard, and they realize they have absolutely no idea what they are actually growing.
I mean, I don't blame them at all.
Really?
Oh, yeah. If you have ever looked at seeds from the allium family.
What does that include again?
So that includes standard yellow onions, red onions, leeks, spring onions, and of course, chives. The seeds themselves are practically indistinguishable from one another.
Oh, wow. So they all just look exactly the same.
Pretty much. You are essentially looking at a handful of tiny, hard, black, geometric specks.
So it's just a complete botanical lottery. You plant it, and you just hope for the best.
Exactly. And the confusion, it doesn't stop at the seed stage either.
Right, because of the shoots.
Yeah, even when those seeds finally break through the soil, those initial green threads all look entirely identical. You could be nurturing a giant leek or a delicate little chive, and you won't know for weeks.
Right, so Kesser, who clearly wants to bypass this whole waiting game,
Yeah.
he decides to take a shortcut. He goes and digs up an old pot of chives that he actually grew last spring.
A very smart move.
Yeah, the notes mention he had planted them out previously and set them on top of a larger pot filled with this really rich homemade compost. So he brings this mature, supposedly glorious pot in to show Steen. The only problem is it looks absolutely terrible.
I imagine it just looks like a bucket of dead waste.
Yeah, waste is like the polite term for it. It's just a giant, withered, crusty lump of dried brown stems. I mean, if you get right up close and squint, you might see a couple of microscopic green tips buried in the debris, but to any normal person, it looks completely and utterly dead. And Steen, who is apparently incredibly impatient to get his own home kitchen garden looking, lush and productive, takes one look at this thing and is totally ready to launch it straight into the garbage. He just wants to kick it to the curb and start fresh.
Well, Steen's reaction makes total psychological sense.
You think?
Oh, definitely. If you are a student eager to build a vibrant garden, a withered mass of old roots feels like a failure. You want lush green leaves, not something that looks like you forgot to water it for 8 months.
Fair point.
Yeah.
But here is where the dynamic between the two students gets really funny, and where Kesser steps in to save the day. He stops Steen from throwing it away, but not with, a science lecture. He uses pure household politics.
This part is hilarious.
It really is. The notes point out that Kesser knows Steen's mother is notoriously, and they actually use the word hysterical here.
Wow.
Yeah, hysterical when it comes to her garden aesthetics. She is incredibly picky. So Kesser basically tells Steen, look, your mom would never, in a million years, approve of this ugly, dead-looking lump sitting out on her patio. She'd lose her mind.
So the motivation to save the plant isn't purely botanical, is self-preservation against Steen's mother.
Exactly.
Yeah.
Kesser insists they have to treat this lump like a pampered baby. They literally sit there and give this crusty dirt clod a spa treatment.
Which is exactly what it needed.
Yeah, they start painstakingly peeling off all the dry, dead outer layers, cleaning it up just to make the pot look presentable enough so Steen's mom won't immediately throw it in the compost bin. But as they're doing this, I have to ask you, what is actually going on beneath the surface?
That's the real question.
Because to me, this dead-looking clump feels a lot like a bear in hibernation. Like, it looks inactive on the outside, but it's just sleeping, right?
I see the hibernation angle, but a bear implies the entire organism is just rusting. What is happening with Allium sconoprasum?
Which is a scientific name for chives.
Right, what's happening there is much more of a strategic retreat. The key here is understanding that chives are bulbous plants.
Okay.
The magic, the actual core of the plant, isn't above ground at all. Underneath the soil, chives have these small, whitish, oblong bulbs.
So the green parts we see on top in the summer are, what, essentially disposable?
Entirely disposable. Chives are biologically designed to die back completely in the winter. All that dry, withered foliage that Steen was so disgusted by,
Yeah.
that is just the plant's discarded summer wardrobe.
Wow.
During the late part of the growing season, the plant makes a very calculated shift. It stops focusing on pushing out new leaves for photosynthesis, and instead it funnels vast amounts of energy straight down into those little white bulbs underground.
So it's actively hoarding power while the top dies off.
Exactly. It's basically building a battery pack, and this hidden energy reserve is the exact reason why the plant can survive the freezing winter and then suddenly explode into growth when spring arrives.
That makes so much sense.
Yeah, as soon as the soil warms up and moisture hits those roots, the chives do not have to start from scratch the way Kesser and Steen's tiny seeds do. They have a massive, fully charged battery just waiting to be switched on.
Okay, so when Kesser and Steen were peeling away those dead layers, they weren't just making it look pretty for Steen's mom, they were actually, like, clearing the runway for all that stored energy to push up new, unobstructed growth.
Whether they knew it or not, yes, they were removing the physical barrier of the dead tissue, and it highlights a really crucial lesson for anyone trying to grow these.
Which is?
If you want that explosive leaf production in the spring, you absolutely must let the plant rest in the late summer and fall. You have to let it gather that energy and retreat into those bulbs.
You can't drain the battery right before winter.
Right.
Okay, so we've got the energy stored underground, the dead layers are peeled away, and the chives are waking up. But let's look at what happens when this plant actually gets going. Because the ultimate goal for Kesser, Steen, and pretty much anyone listening is to eventually eat these things.
Right, of course. And this is where the biology of the plant shifts from being a neat survival trick to being incredibly useful for us in the kitchen.
But the instructions in the class notes on how to harvest them present this really wild contradiction. They state that if you want your chives to thrive, especially if they are looking a bit straggly, you shouldn't just trim the tips gently.
No, you shouldn't.
You should shave them right down to the base, which, I mean, it sounds incredibly harsh, doesn't it?
It sounds like plant murder.
It really does. Like I said at the start, if I decapitate a tomato plant, it's game over. How can a plant survive being chopped down to the soil line over and over again for our egg sandwiches?
That's a great question.
To me, it sounds like pulling from a roll of birthday wrapping paper. You just endlessly unroll it, cut off what you need, and there's always more underneath.
I understand the wrapping paper visual, the idea of a continuous feed, but wrapping paper implies a finite roll that eventually runs out of paper.
Okay, true.
A better way to look at this is like a biological 3D printer stationed at the very bottom of the plant, one that never stops printing as long as you feed it water and sunlight.
Oh, I like that.
Yeah, you aren't just unrolling existing material, you are triggering the active generation of brand new tissue.
Okay, so where is this 3D printer located, and why doesn't my tomato plant have one?
It comes down to evolutionary family trees. Chives belong to the Liliaceae family, and more importantly, they are monocots.
Monocots, okay.
Yeah. The tomato plant you keep threatening with scissors is a dicot. Dicots typically have their growth factories.
The places where they make new cells.
Right, the active growing points where cells divide. In a dicot, those are located at the very tips of their stems or the ends of their branches.
Right, the new tiny leaves always sprout out of the very top of the branch.
Exactly. So if you chop the top off a tomato plant, you are physically throwing the factory in the trash. The plant undergoes massive trauma. It has to reroute its internal energy, panic, and try to build a whole new factory somewhere else lower down on the stem.
Which sounds exhausting.
It is a slow, stressful process. But monocots, like our chives, have a completely different architecture. Their growth factory is called a basal meristem.
Basal meaning base.
Right. It is tucked safely away at the very bottom of the plant, hovering right at the soil line, just above those little white bulbs.
Wait, hold on. So when I come in with my scissors and snip off a bunch of chives to put on a baked potato, I'm not actually cutting the growing part of the plant.
Not at all. You are only removing the older existing tissue. The factory itself, the basal meristem that produces the cells, is completely unharmed. It's sitting safely below the blades of your scissors.
So the plant doesn't even register the cut as trauma. It just registers it as like an open lane.
It registers it as a sudden shift in resource demand. Think about the mechanics of what happens the moment you cut those leaves. The plant instantly loses its solar panels, right?
Yeah.
But remember those roots and bulbs underground. They are currently packed full of water and that hoarded energy.
The battery pack is still plugged in.
Exactly. So the root system experiences this immediate pressure shift. It sends a rapid signal to the basal meristem saying, hey, we've lost our light source. We need new leaves immediately.
Wow.
And because the 3D printer is completely intact, it just takes that water and energy, shifts into overdrive, and starts dividing cells rapidly at the base. This physical division of cells literally pushes the new, fresh green tissue straight up from the bottom.
It just shoves the plant upward from the dirt.
Yes, and this isn't just a quirk of chives. This is the exact same evolutionary mechanism that allows the grass on your lawn to survive being mowed week after week all summer long.
No way. Grass does this too.
Yeah, grass is also a monocot with a basal meristem. When you mow your lawn, you are just giving it a haircut, leaving the engine perfectly safe in the soil.
That is wild. So when Kesser and Steen are looking at this sad, withered clump that Steen wants to throw in the garbage, they aren't looking at a dying plant. They are looking at a perfectly intact, fully fueled engine that just needs to be switched on.
And once that engine is switched on, their problem is going to shift very drastically. They are going to go from having a dead-looking plant to having a space management crisis.
Okay, yeah, let's explore that. Because the notes make it very clear that knowing about this indestructible basal meristem engine is really only half the battle.
Huh.
What do Kesser and Steen actually do with this revitalized clump once it starts growing? Because as that 3D printer works, the plant doesn't just grow taller, does it? It grows outward.
It has to. As the basal meristem produces more foliage above ground, the plant is also reproducing its underground infrastructure. Those small white bulbs begin to multiply and divide beneath the soil.
Oh, I see.
Yeah, and as they multiply, the plant expands its physical footprint, forming a very tight, dense block of vegetation.
And a single pot can only hold so much of that before it bursts.
Right. If left alone in a confined space indefinitely, they will eventually crowd themselves out. The bulbs will compete for water and nutrients, and the center of the tuft might actually start to die off.
Which brings us to the next massive realization for Kesser and Steen. To manage this crowding, they have to divide and conquer. They have to split the pot.
Yes.
And this is the part of the notes that I find absolutely fascinating because it feels like a total glitch in the matrix. You can take this single, densely packed block of chives and you literally just rip it apart. And it doesn't hurt the plant.
Well, rip might be a slightly aggressive term, but yeah, you basically pull the root mass apart.
It just pulls apart.
Yeah, because you aren't dealing with one massive singular root system like a tree. You are dealing with a colony.
Right. The notes say that one single mature block of chives, like the kind of ugly lump Kesser brought in, can contain 30 to 50 individual bulb plants.
It's incredible.
50, just hiding in one pot.
It is a remarkable return on investment from a biological standpoint. The plant does the multiplying for you.
It really does. So, practically speaking, if someone listening wants to replicate Kesser and Steen's rescue mission, how do they handle the division? The notes recommend that once you pull this tight tuft out of the pot, you gently tease the roots apart, breaking that giant clump of 50 down into much smaller clusters.
Usually you want to divide them into little groups of about 2 to 3 plants each.
Okay.
That gives the bulbs enough company to establish quickly, but plenty of physical space to begin multiplying all over again.
So suddenly, Kesser and Steen's one single rescued pot, the ugly dirt clod from last year, becomes an entire row of fresh herbs. They go from zero to a massive harvest just by understanding how the bulbs clump together.
It is the ultimate propagation hack. And traditionally, because they form these incredibly neat grassy clumps when they grow, chives have been used as fantastic edging plants in kitchen gardens. You don't just have to put them in a pot. You can line the entire border of your garden bed with them.
Okay, but what if you are listening to this right now and you don't happen to have a friend like Kesser to just hand you a majestic, oversized pot of compost-rich chives?
Right.
How do you get in on this without spending months staring at cardboard paper towel tubes, hoping a black speck turns into a chive instead of a yellow onion?
Well, there are a few strategies. The most straightforward route is simply going to a garden center in May and buying a tray of seedlings that are ready to go straight into the ground.
Sure, but the Norts suggest a method that is infinitely more entertaining.
They do. The fastest, most traditional, and certainly the cheapest way to get a robust chive patch is to go on a local scouting mission.
I love this part.
You visit a friend's garden or peer over a neighbor's fence, and you keep your eyes peeled for an overgrown row of chives that clearly needs to be divided anyway.
And then you deploy the sweet talking.
Exactly. You point out that their chives are looking a bit crowded, and you offer to help them manage it. You just ask them to take a spade and slice a chunk off the end of their row for you.
It's brilliant.
Yeah.
You're like, hey, I'm doing you a favor by taking this off your hands.
And the thing is, it is a genuine favor. It benefits their plant by relieving the crowding, allowing the remaining bulbs more space and nutrients.
Oh, true.
And in return, it gives you a mature block of 30 to 50 plants immediately. You completely bypass the fragile germination stage that Kesser and Steen were initially struggling with.
It is a total win-win.
Yeah.
And, we've spent this entire deep dive talking about chopping them down, shaving them to the base, and eating them. But the notes actually point out a really beautiful ecological nuance to all this, too.
Yes, they do.
You don't have to treat them like a constantly running factory.
Yeah.
If you let some of these plants establish themselves and just leave them alone, they do something pretty spectacular in the early summer.
The blooming phase. It's beautiful.
Yeah.
If they are allowed to mature without their leaves being continuously harvested, right around May and June, they shift their energy away from leaf production, and they produce these stunning, light purple spherical flowers on top of rigid stalks.
And those flowers aren't just there to look pretty in Steen's mom's garden, right?
Not at all. Those blossoms are an absolute magnet for local pollinators.
Really?
Oh, yeah. Wild bees specifically, along with various other insects, just flock to chive flowers. They provide a crucial, dense source of nectar relatively early in the season when a lot of other plants haven't even started blooming yet.
Oh, that's amazing.
So maintaining a patch of chives isn't just a selfish act for your kitchen. It is actively supporting the local ecosystem.
I love that dual purpose. You can hack half the row down to feed yourself and let the other half bloom to feed the wild bees.
Exactly.
Oh, and as a quick culinary side note, the notes mention that if you ever get tired of the standard onion-like flavor, you can branch out into Chinese chives, which are also known as garlic chives.
A fantastic alternative. They operate on the exact same biological principles.
The bulbs, the basal meristem, the multiplication.
All of it. But they have a distinct physical appearance and flavor profile. Instead of the hollow, tubular leaves of standard chives, Chinese chives have flatter, thicker leaves, and they pack a very strong, distinct garlic punch.
So you could do a row of each and have a complete flavor arsenal.
Definitely.
And after the standard chives finish flowering and the purple blooms start to fade and turn brown, what do you do then?
You simply employ that basal meristem trick all over again.
Just chop it.
Just chop it. You take your shears, cut the whole plant down to the soil line, remove all the spent woody flower stalks, and that sudden loss of top growth triggers the engine again. The plant will push up a brand new, tender crop of fresh green leaves to carry you through the rest of the summer.
It really is an incredible journey when you zoom out and look at what Kesser and Steen actually accomplished with this one little project.
Yeah.
They started with this ugly, crusty, trash-bound lump of dirt that Steen was completely ready to throw away. And just by understanding the biology underneath, by recognizing that the basal meristem engine was waiting and that those bulbs were just hoarding energy, they unlocked this endless, multiplying supply of food.
It fundamentally changes how you perceive the life cycle of the plants around you. It teaches you to stop judging a plant solely by its above-ground appearance in its dormant phase, and to start recognizing the hidden systems operating beneath the soil.
So what does this all mean for you listening right now? It means that as spring cleaning fever hits, you should definitely think twice before you toss out that withered, sad-looking pot sitting on your balcony or patio.
Absolutely.
You might just be holding on to an absolute biological powerhouse that simply needs a splash of water, a little bit of sunshine, and perhaps a harsh haircut to boot up.
A little patience and a little knowledge of anatomy pays off immensely in the garden.
It really does. And honestly, learning about this indestructible basal meristem engine leaves me with one final, lingering question.
What's that?
Well, if chives and longgrass share this incredible superpower, this evolutionary design that allows them to actively thrive and multiply specifically because they get cut down, it makes you wonder,
Yeah.
how many other seemingly dead plants or incredibly stubborn, frustrating weeds in our gardens are secretly playing this exact same game of biological hide and seek, just sitting there in the dirt, totally unfazed, waiting for you to chop their heads off so they can unleash their true potential? Keep an eye on that soil. Have you ever, taken a pair of pruning shears and chopped the top off a fiddly fig,